So now let's see an application of parabolas. We want to look at focal chord length and arc length. Now, a line segment that passes through the focus of a parabola and has endpoints on the parabola is called a focal chord. So we have the focus right here, as you can see, right? There's the focus. And you can have all sorts of lines that go through that particular point and touch the parabola. But there's one in particular that passes through the focus but is parallel to the directrix. It's perpendicular to the axis of the parabola, and that's called the latus rectum. It literally means the side is straight. So now we want to find the length of the latus rectum of the parabola. X squared equals 36y. Sorry, those of you watching in Spring 25, I changed that, so make it 36y. And then we want to find the length of the parabolic arc that's intercepted by the latus rectum. Okay, so let's start by finding the length of the latus rectum. Right, that means side. That's why your lats are called that, if you know anything about bodybuilding, right? It's abdominal muscles on your sides, right? All right, so lattice. Okay, so before we go any further, let's make a note of a couple things. So I can tell because I know the general form for a parabola. And since it's just x squared and 36y, there's no h and k. And therefore, right, no h, no k, so h and k must be 0, 0. And that means the vertex is at the origin. Interesting. Right, good to know. Oh, and I'm just going to add in here, let's let x and y be in meters. I'll make sure that's there for future. Now, why is it important that the vertex is 0, 0? Well, if we go back here and we see the vertex is hk, but we also see the focus. And the focus is h, comma, k plus p. Interesting. K plus p. So it's going to be 0, comma, 0 plus p, so 0p. So our focus is 0p, right? Because it's on the y-axis. So wait, if the focus is 0p, but wait a second, I know that it's 4py. So I can actually find p right now. So if x squared equals 4py equals 36y, then I know that 4p must be equal to 36, which means p is equal to 9. And therefore, I know this focus is 0, 9. All right, so I know this is 0, 9. Nice. Okay, but let's also keep in mind that we know that x squared is equal to 36y, and we know what the y value is because it's the latus rectum. We know that this point over here is something comma 9, and this point over here is something comma 9. They have to be on the same y value because it's a straight side or straight chord. It's perpendicular to your axis and therefore parallel to the x-axis. The axis of symmetry, perpendicular to the axis of symmetry, and parallel to the axis, the x-axis. Oh, so I know that the y value must be 9. So I can substitute and say, look, I know that x squared equals 36 times 9. And therefore, x is equal to, or x squared, is equal to 9 times 36, which is 324. And therefore x is equal to plus or minus the square root of 324, which is plus or minus 18. Because the square root of 36 is 6, and the square root of 9 is 3, and 6 times 3 is 18. So I know this point over here is 18, and I know this point over here is negative 18, which now means I know that this chord length because this distance right here is 18 units, or meters in this case, and this is 18 meters. And so, putting this all together, the length of the latus rectum would be 18 take away negative 18, which would be 18 plus 18, which would be 36 meters. Done. Well, at least with that piece of it. So now we need to find the length of the parabolic arc. Okay, so the parabolic arc is the part of the parabola that goes from one point where the chord hits, where the latus rectum hits, to the other side. All right, so we need to find the length of that parabolic arc. Length of parabolic arcs are very important for trajectories, by the way. We'll talk about that. Okay, well, arc length, we will remember, we've learned that formula before, is, well, I'll just put it over here. It's the integral from a to b of the square root of 1 plus f prime of x squared dx. Now, I would do a dx in this case because it's a vertical parabola. Therefore, it's a function in x. If it was a horizontal parabola, I would do or g prime of y, if you will, because then it's a function in y. But this particular one's a function in x, like that. Okay, so I need to solve my original equation differently, right? So I need to say that y is equal, so let's make a note. So y is equal to x squared over 36. And therefore, right, this is my function of x. Because the way it's originally written, it's not really a function in anything. It's not solved for y, and nor is it solved for x. It's just kind of sitting there. So we have to solve it for x, or excuse me, for y, but as a function of x. So that way we can find the derivative, right? F y prime, which is f prime of x, would be 2 over 36 times x. In other words, it's x over 18. Okay, so now we can use that and we can substitute. Now, we know that this x value is negative 18, and this x value is positive 18. And we're doing this with respect to x. So we're going to have an arc length from negative 18 to positive 18, square root 1 plus, and then it'll be x over 18 squared dx. Now, because of symmetry, it'll be easier, and it'll also just be easier to type it in. So to say 2 times the integral from 0 to 18 of the square root of 1 plus x squared over whatever 18 squared is. Let me go find that. No, I don't know it off the top of my head. Although when I see it, I'll probably be, oh yes, of course. Of course, it's 324, of course, because we saw it earlier. I should have thought of that. All right, so now let's actually find the integral. Now the integral itself is pretty ugly. I mean, we could use a little bit of algebra to simplify it a little bit and get rid of the fraction, but it's kind of not necessary. It's not worth our time. We're just going to do this with Desmos and make it do the final calculation for us, because that's not an easy integral that's a known thing or anything like that. Well, I shouldn't say that. It's probably in that pink sheet of integrals we have somewhere, the giant table of integrals, but we're not going to go searching for it. All right, so over here in Desmos, I'll take the integral from 2 times the integral from 0 to 18, and then square root of 1 plus, and then x squared divided by 324 dx. And there we have it. So we believe that that arc length is 41.321, if you will, meters. It would have the same unit, of course, as the chord length up above because it's a length. Length only has one dimension. So in this case, it's meters. By the way, when you are going to use a computer software to run an integral, it's just good form to state that that's what you did, to state that you used some type of computer program to actually run the integration on this. And since it didn't say up above that we had to do it fully by hand, then that's completely fair game, right? And nowhere in here does it say it has to be done completely by hand, nor that we need an exact answer. So it's perfectly valid to do the last step with a computer, at least in my opinion.